One of the earliest anaesthetics used was ether, only they didn't really use it as an anaesthetic early on. It was used as a form of entertainment, a very early form of drug abuse. And parties would be set up where people would consume ether, as you can see in the bottle on the bottom left of this image, and this would result in riotous behaviour. As you can see, we have some people here behaving rather indecorously, and it wasn't realised at first that ether could be used as an anaesthetic. So one of the main targets of general anaesthetics is thought to be Gaba-A receptors. The Gaba-A receptors are actually quite complicated molecules. They're ligand-gated ion channels. So normally once the GABA binds somewhere out here, we get the opening of the ion channel, and then ions can flow in or out through this ion channel. So that's how GABA receptors normally act. But GABA receptors are quite complicated because in addition to the GABA binding site, they also have a number of other binding sites as well. So one of these is benzodiazepines, as you can see here. There's also alcohol. GABA receptors are one of the targets for alcohol, but there are also a number of other sites, including barbiturate sites and steroid sites, all of which act as allosteric modulators. And it's thought that that's how some general anaesthetics work, and particularly one of the most important ones, which is Propofol. So what usually happens is that when an allosteric modulator lands on the receptor, nothing happens. You don't see anything. It doesn't open the channel. The allosteric modulator binds and sits there, but what it does is it primes the channel to respond much more vigorously when it does encounter a GABA molecule. So all it's doing is it's silently turning up the sensitivity of this ion channel so that when it does get the message, it responds much more vigorously. The most commonly used general anaesthetic today is Propofol, and this is the structure of Propofol. As you can see, it's quite a simple molecule, and this is what it looks like in 3D. Propofol is known to act as an allosteric potentiator of GABA receptors. Hales and Lambert in 1991 in the British Journal of Pharmacology first showed that Propofol enhances GABA receptors, GABA-A receptor responses, as you can see here. Propofol induces anaesthesia very quickly and also doesn't really leave you with very much of a hangover, and is particularly good for short duration operations. Another target for general anaesthetics are Nmda receptors, that is, receptors, these are glutamate receptors, ligand-gated ion channel glutamate receptors. And they're called Nmda receptors because they are activated by the chemical N-methyl D-aspartate. So essentially it's a subtype of glutamate receptor. And as you may know, glutamate is the most important, or certainly one of the most abundant excitatory neurotransmitters in the brain. Nmda receptors are just as complicated as GABA receptors in that not only do you have this glutamate binding site, the red one in the image here, but you also have a number of allosteric binding sites such as the glycine site, and Nmda receptors don't actually respond at all to glutamate unless glycine is bound, but there are also a number of other binding sites as well. And the important thing here is that some general anaesthetics have been shown to interact with Nmda receptors. For example, ketamine is a direct blocker of Nmda receptors, and at the same time xenon, which is actually a noble gas, it interacts at the glycine coactivator site. So once again, allostery could underlie some anaesthetics, but in the case of ketamine, we've got direct blocking of glutamate receptors. Other anaesthetics still activate two pore domain potassium channels. So those then are the three main targets: GABA receptors, NMDA receptors, and 2-pore potassium channels. So the site of action of the general anaesthetics, you won't be surprised, is in the nervous system, particularly in the thalamus, the midbrain, the hippocampus, and the spinal cord. The thalamus is the main gateway between the lower parts of the nervous system and the cortex, and the midbrain controls a lot of the most basic functions, including consciousness, and the hippocampus controls memory and learning, and the spinal cord is, of course, motor output. In addition to their obvious effects on the central nervous system, which of course are lack of consciousness, lack of motor responses, and what might be called coma, we should also notice that general anaesthetics also affect other systems, including the cardiovascular system. They can affect the heart and the respiratory system and can reduce the rate of respiration. These side effects, of course, need to be monitored carefully.